Hello guys, my name is Devesh Jadwani and welcome to my YouTube channel. So guys, I'm super excited to tell you that in this particular video, we are going to start with RAG for absolute beginners. So whether you are new into this agentic AI space or whether you are exploring RAG, whether you are a student and you don't know where to start from, this is the right place to get the right understanding in very simple words. RAG is Retrieval Augmented Generation. This is the most important, the most basic, and the very first concept which we learn when we speak about AI agents. So what I'm going to do is I'm going to show you an example. All right. So if I go here and if I open chatgpt.com, okay, and if I write, what are my bills for this month? It will not have any answer because we have not given any kind of information of our bills. All right. So what it is saying that I currently do not have any access to your bank accounts or billing statements so that I can see your bills for this month. Right. Now, this is an example of a RAG application. All right. Before even understanding RAG, let us check out the example first so that we understand something. I will add the large language model provider. So I've used Groq again to supply my application with a large language model, a brain. Secondly, I can also configure any kind of brain. All right, we have different kind of brains. This is Gemma made by Google, Llama by Facebook and everything, Meta. Now what I can do is I can upload a document over here. Let me upload a document. See, I can upload a document. And the moment I upload a document, information is extracted about this document and I can simply ask a question. Which is the most attractive place to visit? Let us check what kind of reply we get. The reply we have got is the river park is the most visited attraction. Now, on what basis did we get this information? We got this information from our travel guide document. All right. Similarly, if I go here and I've given this RAG company document, and if I open this document, let us see what is there in this document. Employees may work, core collaboration hours are 10 to 4 p.m. Okay. If I ask without this document, what are core collaboration hours? It's not gonna make sense. All right, see, it's not gonna make sense, and we are going to receive some random response. But now, if I upload a PDF, and now if I ask the same question, and let us see what kind of response do we get now. See, 10 to 4 p.m. during these hours, and this is what was mentioned in this PDF as well. 10 to 4 p.m. So what exactly is happening? We are extracting information from our documents. This is what RAG is. All right. Now let us go ahead and talk about Retrieval-Augmented Generation. This is the topic of concern. This is the topic which we are learning right now. Retrieval-Augmented Generation. RAG, the most famous use cases. A very fun fact, if there are 100 agentic AI or AI application in this world, then almost 98% are RAG applications. 98 to 99% are RAG applications. Slowly, the industry is moving towards agentic AI and multi-agentic systems, but people don't trust them yet. We will talk about why don't people trust them yet. But almost most of the use cases, 98% use cases in this world are RAG-based use cases. We are trying to develop chatbots, assistant, which are answering us questions based on the documents which we have provided. All right, so let us talk about the definition of RAG and things will be pretty simple now. RAG, Retrieval-Augmented Generation, is an AI technique used to connect large language models, all right, to external, private or real-time data sources. I think this is what we did. This is what our application was. What we did was a large language model, any kind of large language model. We connected it with our document database. It was either it is real time or either it is external, private, any kind of data source, and we can extract information out of it. All right, the information which is being extracted from these documents, see, this is AI, a large language model. We'll just write it. This is AI, a large language model, and this is a document. This is a document. We are trying to get some information from this document and pass this to our large language model. The form of information or the information which is being retrieved from the document to the large language model is called as context. Okay, context. It is very simple, people. If I just ask you, if you, I have not provided you with this PDF. Okay, if I have not provided you this PDF, let us open this. You don't know nothing about this PDF, and I just simply ask you that, what is the time when City Museum opens? You will ask me, hey, which city museum, what city museum? I don't know nothing about this city museum. But when I provide you that, hey, City Museum opens at 9 to 6 p.m. and I tell you some information about this, and if someone else will ask you the same question, then you will be able to give the response that, all right, I know City Museum opens from 9 a.m. to 6 p.m., which means you know the context. All right, I will spend one more minute in explaining you this concept of context. Two people are talking, person 1 and person 2. Both of them are in a conversation. Both of them are talking about AI agents, and one is telling about how AI agents is used for HR policies in his company. Second person is telling how AI is used for making PowerPoint presentations in his company. Both of them are talking. Now we have a third person coming into the picture. He is here, he is not understanding anything about what they both are talking. So he will ask them, hey, tell me also what you guys are talking about. So both of them will tell him that, hey, we were talking that how we are using AI agents in our company. And then this guy will also contribute. All right, so in my company also we are using AI agents for coding, right? Once he got the context of the topic, then he was able to answer the question better. So this is what the term context is, right? Are you understanding this word context, people?
Yes.
All right, amazing. Now let us talk about the use cases of RAG. The most famous use cases of RAG is chatbots. Chatbots are the first and the most widely used cases of retrieval-augmented generation use cases. Now, what is this retrieval-augmented generation? It is really simple. We are retrieving, which means we are extracting information from some document. Okay. Now there can be one document or there can be multiple documents. Okay. Instead of documents, there can be different sources of information. I will just demonstrate that in 1 minute. Once we are collecting lot of information from different places. So this is information source 1, source 2, source 3, source 4. From all these sources, we extracted some information and we augmented it as one information, right? Similarly, when we were kids, we used to study from different sources. One is our teacher taught us something. One, we understood something from the digest, right? One was some last year question paper. We used to collect all the information from these different sources. And finally, we used to build our master bank in our master notes, something like that. And that we used to use for giving the exam, right? We retrieved information from different sources. We augmented all of that on one place, and then we generate better information based on the information we have. This is retrieval augmented generation. Who is generating? AI model is generating. How is it able to generate? Because it has some retrieved information. It has some context. All right. Best use case is chatbot, and other use cases is Gen AI applications. I will show you that. Okay. We can also call them enterprise chatbots and generative AI applications. So yesterday we saw, let us see this example, AI travel planner. right? Plan me a trip to maybe some place, Munnar in Kerala for 3 days. Trip should be relaxed and luxury. See, it will plan a 3-day trip, and let us talk about the kind of sources it is using to extract the information from. First, it is extracting the maps information, the Google Maps information, that where exactly this particular place is located. Then let us list these things out. So if we talk about a travel planner, first it got the information from the maps. Second, it got all the information of the hotels in Munnar. So how did it get the information of hotels in the Munnar? Web search was performed, right? Hotel prices, or maybe some hotel API would be used, agoda.com, tripadvisor.com. They might have partnered with these organizations, and they might have been receiving information from many sources, right? Thirdly, they might also be picking up reviews of hotels, that which hotel was good. If we want to have a luxury trip, which hotel will be the best hotel? And based on all the information, a plan would be generated. All right, this is retrieval augmented generation. Okay, let me also show you this website. See, this was some website, restaurant assistant. All right, this is just a demo. Let us start the demo. What's your most popular pizza? It is telling our most popular pizza. We are proud of, okay, it is just, running some simulation, but our most popular pizza is Margherita Supreme. How was it able to tell that our most popular pizza is Margherita Supreme? Based on what reviews it got, the number of sales they have done, and this all data is being fed to this restaurant assistant. Okay, do you have any gluten-free options? Absolutely, we have several gluten-free options. See, with price and everything. So we are trying to make assistants who is trained on our data to respond better or provide better assistance to the users using our application. And this is what retrieval augmented generation is, right? You can see many websites are leveraging this. In any particular website, in the corner you will see that there is something like this, some chatbot which is trained on their company data, right? Now if we talk about something more interesting, chatbots are also of two kinds. One is rule based chatbot and one is intelligent chatbot. Intelligent chatbots are those chatbots which leverage AI or large language models in the backend, and rule based chatbots are those chatbots where we have defined the moment user is coming, you will ask this and user will reply something of these three. Then based on these three, you will reply this and like this. I will show you a non-intelligent chatbot right now. Check this out. This is some university, DY Patil International University. We have, hey, I am Naika, your admission assistant. Let us open this. It will give us some message. All right. This is rule based. People have programmed this to behave like this. Exactly. It is not intelligent. How can I assist you before we start? So I can just say abc@gmail.com. Okay. I have sent you a OTP. Give your OTP and everything. And once we give OTP, it will list all the courses and everything. So what is going to happen? Here it is working on predefined steps. It is not intelligent. People have programmed this, hard coded this. But here, if we talk about these other things, here people have implemented intelligent systems behind their chatbots, which are trained on this particular data. One more beautiful example. Let us go ahead and see Amazon. This is Amazon. If we just go for any particular product randomly, we can see something called as Rufus. Okay. We should see something. We should have a chatbot over here. I think they've removed it or something because I just checked. All right, we do have a chatbot, but currently it is not visible. Really not a problem. But yeah, chatbots also we have of two kinds, and this is what is a retrieval augmented generation. This much is clear.
Yes.
What is RAG? All right. The very core sentence of RAG is we are feeding our large language model with documents. All right. Let us understand the problem behind this. Problem. Let us talk about how. Let us talk about how and why RAG came into existence. How and why RAG? See, earlier in 2022, when large language models came into existence, ChatGPT was being used. The ChatGPT third version was into existence. And what happened is when we used to ask ChatGPT some questions like, who is the current prime minister? Or what is the current weather at Paris or India or any particular state? We used to get a specific response that, hey, I am trained until 2021 only. I do not have any kind of information after 2021. And this was a very big loop, all right, very big loophole into this system, because what kind of chatbot is this when it does not know what is going on currently? How can we call it intelligent when it does not have any current sources, when it does not have any superpower to fetch current sources or current real-time information? We cannot use it, right? We can only use it for generating that content, right? Writing Instagram posts or LinkedIn posts for all those tasks people were using it earlier, but we cannot get real-time information, which is a very big problem with large language model and the need for RAG. The question which I have sent here is, don't use web and tell me who is the current prime minister of America. So every large language model is trained on some day, right? May it be any Google, Claude, or Gemini, or OpenAI, they will be trained on some date. Let us say even till yesterday they were trained. All right, which means all the information they will be having will be till yesterday, not today, right? So check out this response. The response is, as of my knowledge, cut off in August 2025. The president of United States was Donald Trump, who began his second term in January 2025. It is telling that cutoff date was August 2025. I do not know anything about it. So this was a huge problem, that LLMs are trained till some particular day, and if we want to get the recent information, we are not able to get it, right? This was the biggest reason that why RAG came into existence, right? People were using large language models in their system. LLMs were utilized. But if people want to make a chatbot on their company data, they either had two options. Either train their own large language model, which is very costly. And secondly, think of a solution that what can we do so that we have a chatbot which is, which knows about our data. So the second use case was RAG. Now, what was the problem with this as well? See, companies were okay with doing this as well. This was company data. They wanted to make company specific company chatbots. And the only way earlier was retrain a large language model. Which is also called as fine tuning. We will talk about it some other time. And in this process of fine tuning, we just feed this particular data to our large language model, and then our large language model knows about our data. And people were okay with this, even though it was very costly. People were still using this because they wanted to stay ahead of the technologies. But the problem with this was, we trained a large language model. We will train it on some date, okay? Let us say on 25th May we trained it, right? On 26th June, we have some new data incoming. Okay. On 28th August, we have new data incoming. We continuously have new data incoming in our organization. And now, because this large language model is already trained, we cannot, feed this extra information to this, because we'll have to again retrain, and again costly. And there is a high chance that in the process of retraining it can lose the previous information and work better on the latest information. This is a very huge problem, right? So people were very fed up of this, and then they thought, let us go really simple. Let us think in a software engineer way. What would a software engineer do? And
Connected to the database.
connect it to a database. So they simply connected this large language model to a database. And this database was having data which was either old data, which was either generating real time. And not only one particular database, they can connect it to now 10 different databases. And this large language model can interact with these databases and get the information, right? And that is how RAG came into existence. One of the reason, let us revise it. First reason, old information. Second information, retraining was costly. And due to these reasons, RAG was born. There was another third reason, which is a very famous concept, which is called as hallucination. Hallucination is a very widely famous term in terms of artificial intelligence or agentic AI space. Hallucination. We say that your model hallucinates. Your model will hallucinate. And what does this word hallucination means? Giving wrong response. Okay. We are asking, tell me about the courses you offer at your organization. And the chatbot is replying, this is how to make a coffee, which means question and answer is nowhere relevant. This means the chatbot is hallucinating. Okay, we calculate different hallucination levels before shipping our chatbot in the organization, that now it is ready for use. So hallucination are also calculated in terms of 0 to 1. The lower the hallucination levels, the better the model or your solution is, right? So these were various different reasons RAG came into existence, and this is what Retrieval-Augmented Generation is. Amazing people. Now that you know what is Retrieval-Augmented Generation, let us proceed ahead and talk about the architecture behind these Retrieval-Augmented Generation systems. There are basically two pipelines which come into the picture. The first pipeline is the data ingestion pipeline, and the second pipeline is data retrieval pipeline. So let us go ahead and understand. Now we are proceeding towards a very interesting part of this RAG. We are talking about how these RAG systems are built. And to build these RAG systems, there are particularly two pipelines coming into the picture. One is data ingestion pipeline, and second one is data retrieval pipeline. Okay, the name itself says that we are ingesting data into the large language model, and second part is we are retrieving this information from the large language model. So we'll go ahead and understand this. Before we go ahead and understand the pipelines which I just mentioned, there are two terminologies which we have to understand. One is the context and one is system prompt. Now system prompt is instructions which we provide to our large language model. Now, why do we have to provide instructions to the large language model? We have to provide many instructions. For example, hey, you are a sales chatbot. Hey, you are a customer service chatbot. Your only task is to make sales. If the user is asking about how to make a coffee or something else, do not respond to that. You are a customer care chatbot. You only respond about your SIM card Airtel. If people are asking you about Idea, Docomo, or any particular other SIM card, don't reply. All right. You are a HR policy assistant. Your only job is to respond about HR policies, nothing else. So let us check this out. Let us check this example. HR policy assistant. These are HR documents. These are some documents, remote work and hybrid policy. Acme Crop is the organization, right? Let us go here and let us ask a random question. How to, first let us ask, tell me about Acme Crop. Okay. I think it was Corp. I am Acme Corp HR policy assistant. I can only answer questions about company policies. So it is restricting itself. All right. Again, if I will ask some company related question, that how many vacations do I get per year? It is going to give me some response based on the documents which we have provided for the last 3 years, etc., etc. This is the kind of response we got from these particular documents. All right. If I ask a random question, how to make a coffee? See what's going to happen. I am Acme Crop. My only job is to tell you about company policies. I cannot help you with other kind of questions. So this is why system prompt is needed. We have to tell this large language model that, hey, now you have a responsibility. Now you are something, and always behave in that way. All right. Do not do something else. Right. So this is what system prompt is. And what is context? What is context? This is context. When I talk about this particular question, let me clear this chat. And let us ask a different question. Benefits and compensation philosophy. Okay. I can ask, Acme Crop covers 80% of premier employee plans. Okay. I can just simply ask this particular question. Tell me about premium for employee only plans. Now it will give me the information based on the documents. Let us check that out. See, according to 80%, which is what we saw, exactly 80%, it did not give us the other information. And here it has got some documents from where it fetched our response. The documents which are fetched, this is nothing but context. All right. What is context? The documents it required, the documents it used to give me the response is context. And to fetch these documents, we have a technique. Okay. And these documents are nothing but context. Okay. Context is required for accurate and reliable response. If context will be provided, then only we will be able to give a proper response. Else we will give a hallucinated response. All right. So these were the two terminologies which we have to know before we go anywhere else. And now let us talk about data ingestion pipeline. There are two particular phases in RAG when we talk about RAG. First one is data ingestion and second one is data retrieval. So let us go and talk about it. Data ingestion pipeline. There are 4 steps to this data ingestion pipeline. The very first is load the data. Okay. Second one is cut the data into pieces. Third data is convert this data into numbers. And fourth is store this data into database. I've said it really quick, but let us now talk about it step by step. See, if we talk about data, we have so many varieties of data in this world. We have PDF data, we have HTML kind of data, website data, we have JSON data, we have URL data, we have PowerPoint, we have images, and we have text kind of data. We have so many kinds of data. All right. So we want to take all of this data and first load this into our system. This is the first particular step of data ingestion pipeline. Load your data. All right. Second one is, see people, this is you. All right. And you go to a restaurant. Now you order a 16-inch pizza, right? And this is the pizza. Now you cannot take this entire pizza and eat it. Very simple. All right. Of course, to take this pizza inside you, you will break this pizza into slices, into chunks. All right. If you take this entire pizza in your mouth, it will be information overflow. All right. Or pizza overflow. Similarly, we don't want to give this large language models the entire pizza or the entire data at once. Why? Because all of the large language models comes with something called as context window. Okay. Context window. Now we understand what is context, but context is the information which our large language model needs to give a better response with respect to our data. This is context. But there is something called as context window. All right. If my window is this much, this is my window. If my window is this much, I cannot pass this much big information which is bigger than my window. All right, but what I can do is I can chop this information into pieces, small pieces, something like this, and I can feed small pieces which will fit and pass through my window. This is what I am talking about. Let me go ahead and search something for you. Let us go on to the Google. Let us say you guys are interested in Gemini models made by Google. Gemini models. Okay. I will write Gemini models context window. Gemini models has the longest context window of all. See, they are supporting up to 1 lakh to 2 lakh tokens. Now, tokens means number of words. At one particular point of time, how much words it can take in is called the context window. All right, see, different models have different context windows. They can ingest up to 1500 pages of text, 2 hours of video at once. So huge models we have, right? Context window. So even though a model can take huge amounts of context, we should not feed the entire huge documents at once because there is a chance of hallucination, right? We always want to chop our data properly so that our AI model can take it in properly. We have other small models. See, Gemini has 1 lakh to 2 lakh tokens context window. If we check open source models context window, see what kind of response we will get. 8,000 to 1 million tokens. All right. So see, sorry, this is not the best response. This is the actual response. Gemini was taking 1 lakh tokens. It is taking 128k tokens, 256k tokens, right? Small tokens it is taking. Gemma 2 open source model, it is taking 8k tokens, right? So I hope we are understanding this, that there is a context window which a large language model can take in, right? And this is what we are talking about, context window. So every time, once you load the entire data, chop the data into pieces and move ahead. All right. So this is the second part, chop your data. And this chop is not a terminology. The terminology is split or chunk your data. Okay. So the steps are data loading. Second step is data chunking. Third step is data vectorizing. Okay. So let us not directly use this term. We will use data embedding. Okay. Data embedding. Now what is embedding? Embedding means numerical representation of these documents. These are some documents. Let me make it simple for you now. All right. Check this out. This is my text file. In my text file, I have multiple sentences that my name is Divesh, I am a mentor, I am teaching agentic AI, and etc. etc. We know we cannot feed this data directly. So we have to split this data. So what I did, I made splits. First split, second split, third split, fourth split. Now split can be made according to us. We can decide we want to split on first 500 words. We want to split on first 1000 words. We want to split after every full stop. After every comma we want to split. It is our perspective how we want to split the data. Once we have split this data, what we want to do is we want to convert this data, this text, so which means I am Divesh. I am Divesh will be converted into numbers 0.1, 0.8, 0.9. All right, just some random number. Why? Because check this out. When I am getting information, from my database, I am getting that information based on some similarity score. Okay, I will talk about it. But check this out. See, for every document, I have a score involved, that this is the closest document. This is the closest document, second closest document. This is the third closest document. All right, let us understand this score and the need of we converting our data into numbers. I'm just going to draw a very simple graph in front of you. Okay. This is a game called as cricket. And this is a terminology called as king. All right. Now, when there is a new term coming in between, if I use a new term called as football comes into game kind of category. So football will come here. If we calculate the distance between cricket and football, it will be really less because they both are of game category. But if we calculate the distance between this, football and king, there will be a huge distance involved between both of them. All right. So distance is actually measured in terms of degrees. See, if I just draw a straight line like this, and if I draw a straight line like this will have a lesser degree. But if I draw a straight line like this, and if I draw a straight line like this will have a higher degree. All right, huge distance. These distances are calculated based on cosine similarity. It's all right if you don't understand the term. This is cos angle, right? We are extracting an angle, right? That's why cosine similarity. But take it really simple. I've kept it really simple. If a new term is coming into the picture, for example, football will be more closer to cricket rather than king. But if a new term is coming like queen, let us say queen has come into existence, queen will be much more nearer to this rather than cricket or football, right? This is what similarity is, right? Similar terms are kept together based on these embeddings. Now this king and queen wasn't directly placed. There was a number involved. There was a number of king and there was a number of queen. All right, so how it works is, now let me make it more clearer to you. This is king and king has some number 0.8, 0.3, 0.2. This is cricket. Cricket has some number 0.1, 0.9 and 0.8. We have a new input coming into the picture. The new input, this is the new input, whose number is 0.7, 0.2 and 0.1. If we compare this number with both of these numbers, let us say the word is queen. Okay, and this is king. And this is some football, okay, or cricket. All right, the moment this new term is come into the picture, this will be compared with both of them. And it will be plotted closest to this king. All right, or it will be plotted somewhere. The moment new term has come, it will be plotted somewhere on the map. And once this is plotted, distance will be calculated with all the different objects in the map. And with the closest distance will be picked as the most similar item. So similarly, the moment a new question is coming that tell me about the premium employee plans, our system is checking the entire database. It is not checking one, it is checking the entire database. And after checking the entire database, it is calculating scores that this particular document has this much similarity. Other document has this much similarity. Third document has this much similarity. And based on the similarity scores, we fetch the top 3 similar documents. We can decide how many top documents we want to fetch. And based on these top documents, our system gives us a response. And that is what is the need of converting data into numbers. And this is called as data embedding. All right, this is the second last step of data ingestion. Once our data is converted into numbers, see, data loaded, data chunked, and all of these chunks are converted into small numbers. And then what we will do with these numbers, because if we have 1000 documents, we cannot just store in the system memory. It will be vanished. We want to use a database to store it, so that when we have new information, we can add new information in the database. And then last step is take all of this data and store in a database. This database is called vector database. What is a vector database? A database which stores only vectors. That is it. And what are vectors? These are vectors. It will store only these things. Only vectors it will store. And based on these vectors, every time a new query comes into the picture, let us see another example. Mid-year check-in is conducted in July. So I can just ask, when is mid-year in conducted? When is mid-year in check-in conducted? It will properly tell me July. All right, let us check. July. How? It went into all the documents. It fetched for the proper document which was suiting us, conducted in July. See, this is what we got, right? This was the most similar document, and based on the similar document, it gave me the replies. And this is what the reply was, right? So this is what is called data ingestion pipeline. We are still on the first phase, that we have to inject some data into the database. All right. So now we are moving towards the better part, or now we are moving towards the second part of our RAG pipeline, which is data retrieval pipeline. In the first pipeline, we took the data, we stored this data into a vector database. Now the next pipeline, this is the retrieval pipeline. So let me show you this, what we are seeing currently in action when we are able to chat with our document and everything. This is the retrieval pipeline. All right, we never saw the data ingestion pipeline. I will show you the data ingestion pipeline as well. But this, when we are using it for our task or for our purposes, that is when it is data ingestion, data retrieval pipeline, which means now we are retrieving the ingested data. Let us check this out. This is very simple. So how it works is, a new question will come into the picture. If we talk about HR policies, so what is the policy for vacation will be the question. Now what is going to happen is, the moment a new question is come, it will be converted into numbers, 0.1, 0.3, 0.9 something. And after it is converted into vectors, it will be compared with all the vectors in the database. Once it is converted and we fetch the top similar documents or top similar information, it is passed ahead. Okay, it is passed ahead, and then we have a prompt. Then we have a system prompt. Okay, this is what I was talking about, system prompt. Now in here we have programmed that, hey, you are a HR agent. Always use English professional tone and always answer in 2 to 3 sentences, because we know the behavior of AI. If we ask it a small question, it will give us a huge response. Let us see that in action. Okay. If I go here, what is cricket? Let us see what kind of response we get. See, I just wanted to know cricket is a game, but it gave me a lot of information. So we don't want that. So we want to restrict its behavior in a certain way that, hey, only answer in 2 to 3 sentences if it is needed. And you are a HR assistant, do not answer any other questions. Always use English and professional tone to answer the questions. And this system prompt, the instructions and the retrieved context, all of this together will be passed to our large language model, to the brain. Okay. And then it will give us the response to the user. All right, people, wasn't that so simple? Data ingestion and data retrieval pipeline, just 2 simple systems in retrieval-augmented generation, right? So now you might be thinking that, do we have a variety of vector databases, or do we have only one vector database? So that is where we are going towards, and we will understand the different kind of vector databases which we require to make these RAG systems. Types of vector databases. All right. Now we have different kind of vector databases. First one is in memory. Okay. Second one is persistent. And third one is cloud databases. Now, when you are developing a proof of concept, POC, right? And let me first tell you what are the different types. In memory means it will not be stored anywhere. It will be stored only for that particular session or memory. Only for that particular interaction. For example, this document which I have shown you, this is in memory. Okay, I am not using any database from in the backend. This is in memory. All right, which means once I refresh, all of this will be gone. And once I enter my key again, see, once I refresh, all of this will be lost. And once I enter this, and then it will internally hit or internally store the data. All right. I'm audible, right?
Yeah.
Just a second, I think. All right. So in memory, there is no particular storage required for this. All right. Second one is persistent, which actually uses some memory in your computer, which means it will make a folder in your computer and it will store this store the vectors in your computer space, so that when you restart the computer, that data will already be loaded. You don't have to worry about it. All right. Third one is cloud. Cloud is simple. You will not be storing this data in your memory, not in any folder on your computer. It will be stored on the cloud. Okay. So data stored on cloud. What are the names of the vector databases which you use in memory and in persistent? So the names for both of these, when you use locally, when you develop something locally. So I was talking about proof of concept, right? When you develop a small prototype for someone to show it to someone, at that particular time, you don't go for any cloud services. You just use what is available natively. Or when you want to develop a really small solution where, you don't have huge data coming in, that is time when you can use local databases. Local databases are the databases which do not store the data on clouds. So again, these are the types of databases, but where do we store these databases? Locally. Sorry, I will not write it. I will write it here. You store it locally or you store it on cloud. As simple as that. Now, what are the names of those databases? Just how we have LLM providers, right? Gemini, Groq. So which particular technology? So the name of that particular technology is Chroma and FIAS, Facebook AI Similarity Index. Okay, sorry, Facebook AI Similarity Search. This is developed by Meta and this is Chroma, an organization. They have made it. All right, let us talk about the cloud solutions. We have Quadrant DB, the most famous. Second is Astra DB, the second most famous. Third is we have Pinecone. Fourth is we have VV8. Right? These are different cloud databases which we can use to store our vectors. All right. What is your assignment gonna be? You will explore all of these. Assignment: explore all the vector databases. In this process, you will also understand what is vector database. And second, you will also understand that what are the different kind of vector databases. All right. So what are we doing? We are making you familiar and comfortable with all the different technologies existing for this agentic AI space. We are starting with all of these, right? So how will you do all of these? I can simply just go here. I can search Quadrant DB. See, if I open Quadrant database, I can see this is the website, right? Again, this will also have a documentation. You can go to the documentation. You can read about this, right? That what is Quadrant DB, how you can store your data, why do we need it. Apart from this, there will also be something called as GitHub. See, if you go to GitHub, you will see how many stars it has. This is the community level of, Quadrant DB, right? You can read about it. Secondly, we have Astra DB, right? This is by DataStax. If I go to Astra DB, all right, we have to log in. I can just simply go to the documentation page and see here you can read about Astra DB. Astra DB is also one of the amazing databases. Okay, I've always used it. It is also, compatible with LangChain. See, so you can read about it, right? What are these different words, right? So quick start for collections. What do we mean by collection? So let me talk about a terminology involved in this. Collection means bunch of objects. That's it. Bunch of objects. What is an object? You remember in one object we have three things. What are the three things we can have in an object? Does anyone remember that?
We can have variables, we can have functions or methods, and
all right, see, let us say this is the sentence and we have converted this sentence into a number, some random number. All right, what we will have in an object is, first we will have an index, that this is the first object. Secondly, we will have the actual text. And third, we will have the numerical representation of the text. This is what an object is. And many such objects form up a collection. Just a terminology for vector database, right? So this is what it is, how to make collections, right? Because in a database, you will have multiple collections. So you can maintain different databases as well, right? And how will you use this cloud databases? Again, for every cloud database, you will have an API key. You can just take this API key and you can access the cloud database. Similarly for this, similarly for Quadrant, and similarly for Pinecone. Okay, Pinecone, the vector database, and you can read about it, resources, products, Pinecone database, view documentation, and again you can see here also ask assistant. So I'm showing you a RAG use case. Can I store image vectors in Pinecone? So it will search this Pinecone website and it will give me the information about my answer, that yes, Pinecone is designed to do all of this. And if you want to read more about it, check out these documents, and I can directly go to the document and I can read it, right? This is the use case of RAG. We are just seeing it live, that 98 to 99% of use cases are all RAG and RAG. All right. So yeah, I hope you get it. Now, now given this, we know the data ingestion pipeline. Now let us talk about the next pipeline. Currently, what has happened? Currently, we have a vector database. Okay, we have a vector database which has stored collections of our data, and one collection has multiple objects, right? This is stored in the vector database. We are proceeding towards the next pipeline. All right, data retrieval is the process of extracting context from vector DB to feed our large language model, so that our large language model can give us a better response. All right. So what is going to happen? The moment a user query is going to come, that what is vector database, this will be converted into numbers, right? 0.1, 0.2, 0.8. Now what is going to happen after this? The moment new user query has come, what is going to happen is this query will be converted into a vector. This vector will be compared with all the collections, first collection, second collection, third, fourth, and fifth collection. Let us say, depending upon the vector, the closest collections were fourth, third, and second. So what is going to happen? Retrieval phase is going to happen. In this retrieval phase, this new query will be compared to all the collections in the vector database, and we will get the top similar vectors. So the top similar vectors or the collections were fourth, sixth, and third. All right, these were the top similar collections. Once we have the similar collections, the next step is we will have a system prompt. Now system prompt is nothing but instructions to our large language model that this is how you want to behave. Then we will have large language model, and then large language model will give us a response. So that was all about different type of vector databases to develop these RAG systems, and I hope you have done your assignment well. Now let us just go ahead and talk about the drawbacks of these RAG systems. Now we are talking about the drawbacks of RAG. Everything which we were studying till now was called a traditional RAG. What makes it traditional? Okay, what makes it traditional is it is not dynamic in nature, right? What we can see over here is a chain of process. Do we agree? Yes, we see a chain of process. What do I mean by chain of process? Right? Every time a new user query will come, let us say the new user query is how to make a coffee. If this is the new user query, all right. And let us say we are also fine with the RAG responding that how to make a coffee. If the question is how to make a coffee, there is no need to go ahead and hit your vector database, because there is no such concern. If the RAG system is made for HR documents and the question is regarding coffee, we will never go and hit our database. We will directly give the large language model the question and the response should be generated. All right. So this is the drawback, right? And what we can see, there is a chain being followed. Okay, there is a simple mechanism being followed. One by one step is being followed. But if the question is not relevant, then still we are hitting the database and then we are fetching wrong context. Wrong information is being fed to our large language model. We don't want that. All right. So this is the first part, that this is the first drawback, always hits the vector database. All right. Second one is no context engineering. What do I mean by no context engineering? So let us say a new user query has come. A new user query has come. This is converted into numbers. And after hitting the vector database, we have received all these information, right? We have received all these collections. Now let us say this collection is the most important, even though the mathematical function has failed. But if a human will read it, the human will say that this function is more important. I mean, this collection is more important than this collection. And if we reorder them, this will be the first, this will be the second, this will be the third, this will be the fourth, and this will be the fifth. Okay. So what this is called, reordering the collections which we are doing, it is called as context management. Okay, context management. Context management is a very huge and a very important topic. Why? Because context management is all about how are we getting context. This is what context management is. How are we getting context? So if the process of getting the context will be best, the retrieval will also be the best. If the context only we are not fetching it properly, then it will be the worst. All right. So even though you fetched the top 5 chunks, but the order in which you fetched was not correct. Okay. This process is called re-ranking. In the traditional RAG, there is no such concept as re-ranking. All right. Secondly, chunking, right? I told you about chunking when we were, cutting them into 1,000 and 500 overlap, 50 overlap, something like this. This was okay. But what was happening is, let us say many documents are being chunked together. Let us say we have document 1 and this gave us 3 slices. We have document 2 which gave us 5 slices. All right, this is happening parallelly. And when all of this is going in a vector database, okay, so in the order in which they are going is, this is the first, this is the second, this is the third, this is the fourth, fifth and sixth. All right, so order is lost, everything is lost, which means after the first collection we will have some other data, other collection. All right, we don't want that. We want to keep the similar chunks together, and this process is called as semantic chunking. Okay, also when this is the sentence, I am Divesh, and second sentence is, I am a mentor at XYZ organization. All right, so semantic chunking means one chunk, this chunking will be dynamic. One chunk will be created of I am Divesh, and second chunk will be created properly of I am a mentor at XYZ organization. Semantic, the word semantic means meaningful. So we are not chunking this meaningfully, right? This is the second drawback of traditional RAG, of what we were studying till now. All right. The third drawback is latency with scaling. When we go ahead, and these are just 2 documents, when we have 10,000 or 1 lakh documents in our vector database, that time the similarity operation which we will be running will be a little slower. All right. So scaling means increasing or expanding the process. When we are expanding the process, the response rate is getting slower. We are getting slower responses with high traffic of users or high information of data. Latency, we are achieving slow responses. And thirdly, no security for sensitive documents. All right, so these were the drawbacks of traditional RAG system. So that is it, people. You have successfully understood the fundamentals of retrieval augmented generation, and that is all you need to get started with RAG systems. I hope you liked the video, and I hope to see you soon in the further videos.